Hello everyone. Today we will learn about conversion of rational numbers into decimal and decimal numbers into rational numbers. So let us start with decimal representation of rational numbers. We know that fractions can be expressed as decimals. We also know that fractions are rational numbers. Here we shall learn how to express rational numbers as decimals and vice versa. A rational number can be changed into decimal either by long division method or by writing an equivalent rational number with the denominator as 10 or a power of 10, or we can say 10, 100, thousands, 10,000s, etc. And then we express the equivalent rational number as decimals. Let us first start by long division method. Convert 1 by 8 into decimals. Let us divide 1 by 8. 1 is smaller than 8, so it cannot divide easily. So we put 8 0 times 0, and when we subtract we get remainder as 1. Then we take decimal here in the question place, and we are allowed to take 0 next to this remaining number. Then it is becoming 10. Now 8 1 times 8, then subtracting it we are left with 2. As decimal is already there, so we are allowed to take one more 0. 1 time 1 0 is allowed, so it will become 2 0 20. And now 8 2 times gives 16, which is less than number 20. We subtract 16 from 20, we get 4. Now as decimal is already there, we take one more 0 next to 4, it becomes 40, and 8 5 times 40. We can see here the remainder is now 0, and our answer is 0.125. So we have converted therefore 1 by 8 in the form of decimal, which is 0.125. Another method, as I have told, by equivalent rational number method. So we have to find such number which when multiplied by this 8, which gives us 10, 100 or 1000, etc. So if we multiply this denominator 8 by 125, we get 1000. So if we are multiplying the denominator by 125, we have to multiply the same with numerator, as we know the property of rational numbers. So we have got here 125 upon 1000, and we can write them in the form of decimals. Each 0 in the denominator represent that there are so many decimal places available in the answer. So 1 2 3 0 says that 3 decimal places are there, and then we put a decimal here. Representation of rational number as decimals can be of two types. One is terminating decimals, another is non-terminating repeating decimals. Now what terminating decimal and non-terminating repeating decimal means? Let us understand it through an example. Minus 3 by 4 is equals to minus 0.75. How it comes? We have divided this 3 by 4, and following the division method we get in the end that there is a remainder 0, and we can see because it's minus 3 by 4, the answer is minus 0.75. Here we can see that the division is getting to an end after few decimal places. That is why we call it as terminating decimal representation. Now what is non-terminating repeating decimals? Let's take an example. 5 by 3. When we divide 5 by 3, performing the normal division, long division method, we see that in the decimal part, number 6, the digit 6 is repeating itself for number of times. By seeing this division, we can see here 2020 is repeating. So repetition begins from here, and here we can see repetition continues, and we cannot still find the end of this division. We are having here 1.6666 and a number of time, endless number of times we can get this 6. We can represent this repetition of any digit by a bar or by a dot. So this kind of division which is not going to any end means non-terminating, and repeating the decimal part of it called repeating decimal. So we can say non-terminating repeating decimals representation. Non-terminating repeating or non-terminating recurring decimal can be further divided into two parts, pure and mixed. That means some rational numbers are pure representation of non-terminating repeating decimals, or some are mixed. What are pure? Let us understand. When we see 5 divided by 3 here, we can see decimal part, that 6 digit 6 is repeating itself for a number of times. It's pure. Why it is pure? Because only one digit is repeating itself so many times. Another example, if we can see minus 12 by 11, when we divide this, we get the result minus 1.090909 and so on. So this is also coming in the category of pure, because a complete set, the whole set, 09 set, is repeating itself for a number of times. We can represent by putting a bar over 09 here, or by putting dots there. You can see the division of the above given example is shown below. Let us understand mixed non-repeating decimals representation with the help of example 5 by 18. When we divide 5 by 18, we get this answer as a result 0.277777. Here we can see 140, and here we can see 140, and then further we can see 140. So repetition begins here and repetition continues here. While seeing this answer, we can find out that only one digit is not repeating, then the other numbers, other digit, that is 7, is repeating itself. So for mixed non-terminating repeating decimals, it is essential that at least one digit should not repeat. Our next topic is conversion of decimal numbers into rational numbers. We have represented a rational number as decimal. We can also perform the reverse process of it. That is, a decimal can be expressed as rational number. To convert a terminating decimal into a rational number, ignoring the decimal point, like for example 0.8. So ignore the decimal point, write 1 below it in the denominator place, and how many decimal places are there, put that number of 0 next to 1, and then convert the P by Q form, the rational number, into the simplest form. We cut this by 2 4 times 8 and 2 5 times 10. So the lowest form of this is 4 by 5. Taking one more example, minus 0.35. We can convert this terminating decimal into rational number. How? We write, for this decimal, in the denominator place we write 1, and 2 decimal places are there. So next to this 1 we write 2 zeros, and then we convert this rational number into the smallest or simplest form. So 5 7 times 35, 5 2 0 20 times 100. So minus 7 by 20 is the simplest form of it. Let us simplify one question. 0.3 multiplied by 0.03 multiplied by 0.003. We first remove all the decimals in all the three numbers. It is 3 by 10, 3 by 100 and 3 by 1000. The product sign is written, so we multiply. There can be any other sign also. So 3 multiplied by 3 multiplied by 3, we get 27. And denominator 10, 100 and 1000 when multiplied, we get this number. So final answer is this. Now, how to convert non-terminating repeating decimals into rational numbers? Let us take an example. 0.6 bar. Let x is equals to 0.6 bar. Bar means that 6 is repeating itself for a number of time. We multiply both the sides by 10 because only one digit is repeating. That means 6. Digit 6 is repeating itself. So 10 multiplied by x and 0.666 and so on multiplied by 10. We know how to multiply by 10. This decimal will be shifted here to the right side. So it will become 6.666, 10x. Now we split this number in this form. We get 0.666 and we know 0.666 is the value of x as we have assumed it. We replace this by x. Now we transport the numbers. This x will come this side and then we simplify it. The answer is 9x here is equals to 6 and the value of x will come 6 by 9, which when we simplify 2 times 6 and 3 times 9, so it will be 2 by 3. So p by q form of 0.6 bar is 2 by 3. Let's take another example. 0.001 and bar over these 3 decimal places. How to convert this into the rational number? Let x is equal to this number. We further multiply both the sides by 1000. Why by 1000? Since 3 digits are repeating, 1, 2 and 3 digits are repeating. 1000 multiplied by x and 0.001001 multiplied by 1000. We know how to multiply them. This will be shifted 3 steps decimal to the right side of it and we get 1.001 here. We split this number in the form to get the value of x. Then we replace this because this is equal to x. We replace this by x. We transport this to the left side. And now when we solve this, we get 999x is equals to 1 and the value of x is equals to 1 upon 999. So this is the p by q form of 0.001 and bar over it. Let us take one example. Earlier 2 examples were the examples of pure non-terminating repeating decimals. Here we are taking the example of a mixed non-terminating repeating decimal. 0.47 and bar over it. Here 4 is not repeating, only 7 is repeating. Now let us consider this as x. And when we open, we know 7 is only repeating itself. We multiply both the sides by 10 since one digit is repeating. Only digit 7 is repeating. So 10 multiplied by x is equals to 0.4777, so on, multiplied by 10. We know how to multiply. This decimal will shift to the right side here and it will become 4.77. We split the figure to get this x value. We know how to simplify it. You can do it very well. And afterwards we replace this value by x. Transporting this x to the left side. Solving it, we get 9x is equals to 4.3, x is equals to 4.3 by 9. Removing the decimal from this 4.3, we get 43 upon 90. And this is the P by Q form of 0.47 over bar over it is equals to 43 by 90. So here we conclude this topic. Thank you for watching.